Hello students. In this video I'm going to go over the Week 8 project. So for this assignment you'll need to use the Week 8 project data, and that is in the file you downloaded during Week 1. Now for the Week 8 midweek assignment you needed to reorganize your data. So you needed to have columns for each year in college, and you need to copy and paste the data so it was set up that way. For the Week 8 project, you do not need to do that. So if you go to the Week 8 tab, the data are already organized that way for you. So you will need to refer back to the lectures when you're working on this. So there is the lecture showing you how to complete the ANOVA. And like I said, you could skip the part where it tells how to organize the data because you won't need to do that. You can just start where it says conduct a one-way ANOVA. And so then you'll also need to have the lecture for the post hoc tests. So for the one-way ANOVA, you'll go to data and then data analysis. You'll pick the single factor ANOVA and click OK. And then you'll select your input range. If there's anything in there already, just to be safe, you should delete it. And then you can select the range of data, including the labels. And then you want to make sure the button is checked by columns, so it's grouped by columns, and you do have labels in the first row. Alpha is 0.05. And then the output range, if you want to do it exactly according to the instructions, you probably want to have it towards the top of the spreadsheet. So I'm going to put my output in E1. And then just click OK. So if any of these columns seem like they're cut off at all, this one is a little bit. You can just click between the columns and it will make it bigger. So the descriptive statistics are up here. Now I notice a lot of students have been interpreting this value the wrong way. So p-values can't be greater than 1. So the p-value is not 3.11. This is scientific notation, and it's just telling you how many zeros are in front of the, come before the decimal place. And I did include a description of that in the Week 7 announcement. So you can just change this. You can click, right-click, and click Format Cells, and then just change to number. And so the p-value won't be 0 either. It just has many decimal places in front of it. So just so we can see that, I'll put it to 8 places. And so you can see that your p-value is very small. So it's a lot less than 0.05. So it's significant, and you do need to do the post hoc tests. So for the post hoc test, you'll need to find the studentized range statistic. And so that is located in the table in the lecture. So this is the lecture, and it tells you how to do the post hoc test using a different example. And so this is the table. So you need to know the number of groups you're testing and the degrees of freedom for within groups source of variation. So going back to the Excel file, so you can see the degrees of freedom for within groups is 69. So we need 3 and 69, and we need to know that alpha is 0.05. And as you've noticed before with the t-test, the table doesn't include all the values. Once it gets to 20, it skips around a little bit, so we'll find the one closest. And so the numbers in bold type are at the significance value of 0.01. So the regular type is 0.05. So we do have 3 groups, and this is the same as in the example. So in the example it had 3 groups, and we have 3 groups. So you'll find the 3 groups, and then you'll scroll all the way down. And so our degrees of freedom error is 69, and the closest to that would be 60. So we get 3.40. And then going back to your Excel file, you can start setting this up. So the studentized statistic is 3.40. And then we're going to need our mean square error. And so our mean square error is 6.96. And then n, in this case, n isn't the total number of people in the data set, as we've used before, but it's degrees of freedom total minus 1. So degrees of freedom total for us would be 71. So 71 minus 1 is 70. And then you can type, it's up to you. I just like to remind myself what this is. So this is mean square within group. And then this is total degrees of freedom minus 1. And then so what we can do now is to use these numbers in the formula. And that will determine our critical value. So we'll have the formula here. I'll call it critical value. And then I want the actual number in this cell. So this is also in this lecture. So this is the formula you're going to use. So you can either refer to the cell that we typed in the number, or you can refer to the actual number. So the number in cell F19, or you can just type that number. So equals F19, and then the asterisk means multiply. And then within parentheses, we're going to type SQRT, so that's for square root. And then another parenthesis, and then we want the value in F20 divided by F21. And the forward slash is for division. And then we need the final closing parenthesis. So at the end, you're going to have 2 parentheses. And then click Enter. So that gives you a critical value of 1.07. So then the next step is you want to find the difference between all of the means. So I'm going to set that up here. So we have the low stress condition minus the medium stress. So remember, with the post hoc test, you're comparing the difference between all the means. So it has to be low stress compared against medium stress, low stress against high stress, medium stress compared against high stress. So I'm going to type all these out. Okay, and then in the next column, or you can go 2 columns over, this is where you'll use your descriptive statistics. So the average is the same as the mean. So in low stress, we have 9.875. So minus, and then the medium stress is 7.5. And you could also set up a formula for that, so we'll go ahead and do that. So equals 9.875 minus 7.5. So that's the mean difference between those two groups. So there's a mean difference of 2.375. So if you look at the numbers, it's the mean difference. The low stress has a higher average than medium stress. And then we do the same thing for low stress versus high stress. So we start out with equal if you want to use the formula. If you just have a calculator, you can do that as well. And then in the high stress, it's 5.2. We'll just round it 5.21. And then click enter. So that's the difference between the low stress and the high stress group. And then for the medium stress, we'll type equal, and then the mean of the medium stress is 7.5 minus high stress is 5.21. Okay, and I'm just double checking. So then what we do now, so you have the difference. And so these could actually be negative numbers. They're not, but if they were negative numbers, what you would want to do is just look at the absolute value. So you would ignore the negative sign if they were negative numbers, but they're not. So what we want to look at is these mean differences compared to the critical value. So in order to be a significant difference, for example, between the low stress group and the medium stress group, the absolute value of this difference would have to be greater than the critical value. And you can see that 2.375 is greater than 1.07. And then the same thing with the low stress versus high stress. In fact, they're all greater than this. So there's a significant difference. So the low stress is significantly different than the medium stress. The low stress is significantly different than the high stress. Medium stress is significantly different than the high stress. And so remember that the dependent variables, we're not saying low stress is higher than medium stress. These are the conditions where the people were put under low stress, medium stress, or high stress, and this is their recall score. So what this means, if you look at it, is that people did better on the recall test, so the participants, when they were in the low stress condition. And that makes sense if you think about it. You know, we always, well, I don't want to say always, but typically if people are under a lot of stress, they're not going to perform as well as when they're under low stress. So the low stress group did the best on the recall test. Medium stress group did the second best, and the worst was in the high stress condition. So remember that variable, the range could be from 0 to 15. So 15 would mean you recalled everything correctly. So the high stress people could only recall about 5.21 of the items. Low stress did the best. So now that you've done that, you need to write an APA formatted interpretation of the results. And an example of this is in the lecture. So the results. So first you want to start out describing the ANOVA, because the ANOVA tells you if there's a significant difference among the means. It doesn't tell you where they're significantly different. And so remember, this description is an example data set. It's not our data set, so you're just using this as an example. So first you report the results of your ANOVA, and then because the ANOVA was significant, you can say that you conducted post hoc tests, and then you would explain the differences. So in our case, all the means were significantly different, so we would have to say that explicitly. You can't just say all the means were different. You would report exactly what I said. The low stress condition did significantly better than the medium stress condition, and you'd report the mean. The low stress condition was significantly better than the high stress, and report the mean and the standard deviation. So you report the actual mean, not the mean difference. So the actual means are up here. So there's a numerical difference, obviously, but what we did with the post hoc test to see if the difference was significant, so statistically significant. And then you would say the medium stress condition performed significantly better on the recall test than the high stress. And you need to do this using APA format. And just one more thing I'll mention is that students have been citing and referencing the textbook when this data set's not from the textbook. So just because you learned information from the textbook, you don't cite and reference that. And you don't need to cite and reference your previous work. So if you didn't mention anything that specifically came from the textbook regarding ANOVA or post-hoc tests, then you don't need to cite or reference anything. Okay, please email me if you have any questions about this.